set. Right, so my circuit problem with it, when I'm using half the circuit, which is the top section, which is halfway basically, and I'm just triggering the on and the off on the half circuit, it works, but because of the diodes and everything, what's happening is when I have it full wave and I have two sections with two MOSFETs, some of the DC pulses are coming from the other side and going all the way through the network, and basically it's feeding back into the system, and it's working opposite to the way it's supposed to work. So when I turn my trimmer pot up, where is it, down here, when I turn the trimmer pot up to height so that it's closer to this diode up here where it should be triggering on, it actually triggers off, it goes off, so it's working back to front and it's not working the way it's supposed to work. So anyway, I put it all out on the breadboard. I'm kind of a little bit stuck right now, but both circuits are separate. That's the one for one half the width of the AC. This one's the other half for the other half of the cycle of the AC. So basically we've got plus and minus volts and that, and then there's my two MOSFETs. Using higher power diodes for the output stage, which is where the AC travels, but all the rest of them are just the 1N914 signal diodes, which is for the anyway, I've disconnected the actually at the moment because it weren't working. It wasn't working right. So yeah. Anyway, so I'm kind of in a bit of a hole at the moment. I'm thinking about this now. A way around that is to basically is to use separate coils so that I have trigger on coil and trigger. I'm getting loads of lag here. It's really bad. The Streamlabs is really lagging out on me. Well, basically, so what I'm saying is I could use separate coils. So I've got trigger on, trigger off, trigger on, trigger off, which means instead of having 4 wires, I would have 8 wires coming in, which are the coloured ones here. So it's getting. I don't want it to get complicated. So I did have it working at halfway, but I didn't bother live streaming anything because it was pitiful, really. The current was pitiful. It was very low. But when I did get this to work in the full wave, I was seeing currents of about 50 milliamps. But it was triggering at the wrong. It was triggering at the wrong point anyway. Really. Yeah, I had the coils actually across here, across these bridges, and I realised I had it wired wrong because I had it wired for half wave and not full wave. So I had these wires down here across these connections, and yeah, that was wrong. So when I put it correctly, wired it according to my diagram, it didn't work. So yeah, I've got things to think about. I'll probably redesign some stuff, but you see, I'm working with a very low voltage on these trigger coils. These trigger coils are producing about 4 or 5 volts. They're not producing enough voltage really. That's RMS basically, but it can be as high as 9 to 12 volts peak to peak, but that's not get through all the circuitry, through the trimmers, and match up with these small capacitors. Well, I've got these tiny little yellow capacitors in here, which they're on the gate to hold the gate on a few microseconds longer than what they would normally be on, to basically keep them on until the off pulse triggers them off. Which these are actually 330 picofarad. These yellow ones, so 330 picofarad. I don't know if you can actually see that. 100 volt. So those are very tiny little things, and I actually upload on the output side, which is this big diode here, and the chuck goes across it and stays with this capacitor, which is just to negate some ringing. I was getting a lot of ringing on my waveform, which is what I don't want. And that works by cancelling out some of the unwanted, and the unwanted resonances can cause false triggerings, which is why I was trying to get rid of them, you see. If you've got ringing on the circuit, it can get quite large, and that ringing can interfere with the gate function, so it's trigger, because it is on the source, which is pretty close to the gate. So when this is ringing on the source pin of the MOSFET, it can affect the gate's triggering as well. So I had to try and get rid of that. And yeah, I just, at the moment, I'm just not feeling enthusiastic. I had some doubts before that this was going to work in full wave because of the way the network of diodes was configured. And as you can see, this section is bridged across through these diodes across down to these other diodes down here. So I've got a lot of feedback going around here, which I don't want. So I'm gonna have to look at separating the two so that they're on separate trigger coils. And yeah, so anyway, that's just a little update on what's going on right now. And the bandwidth is really slow at the moment. My YouTube is lagging out on me. So yeah, I'm gonna keep this short. So you just have to give me time to work this out, because I don't think I'm gonna get sorted out this week. I've got to go back to the drawing, because I can understand the schematics on when I'm drawing the schematic. It makes a lot more sense to me when I'm trying to draw it, when I'm trying to map it out on here, because it's very confusing when you got jumper wires going everywhere. It's very confusing, and it's easy to make mistakes. So yeah, anyway, that's it for now. I'm just going to go back to my schematic and look at separate coils for now. And if I get this secondary stage to work the way I want it to work, I'll come back and make a video and show it. But there's no point in showing you failures, because it just gets boring. Yeah, alright, that's it. If I can get the stop button to come up. Where is the stop? Oh, I have to go back.